Askie, Jeisler, Sanchez.
I'm Juan, Kenneth, Castillo.
And I am Fatima, Tyreza, Juan, and we are to discuss biological materials in engineering methods. Biological materials in engineering methods is the concept of learning from nature through inspiration in design, function, or the combination of both. These are the following materials used to inspire design and functions. First is silk proteins used by spiders and silkworms to construct composite encasement or strong and functional webs to entrap prey. Next is organic or inorganic composite structures found in seashells to form highly engineered, hard and tough materials. Surfaces such as shark skin to reduce hydrodynamic function, and modes of sticking to surfaces used by the gecko to produce strong adhesives, and muscles in the human body to create highly engineered actuators. The first one is silk processing and assembly by insects and spiders, which is the high-performance fibers in nature. Silks are externally spun protein fibers generated by spiders and insects, which of remarkable interest in mechanical properties such as durability, luster, and feel. So, Nephila clavipes is a kind of spider which generates at least 6 different silks from sets of different glands with specific function. Another is real silkworm silks and spider dragline and silkworm cocoon silks, which are considered semi-crystalline materials with a crystal component termed beta sheets. Next is silkworm fibrin, which is a protein that forms the structural aspects of the fibers encased in a family of glue-like sericin proteins, and the native and synthetic silk clones generated in a variety of heterogeneous expression systems, including bacteria, yeast, insect cells, plants, and mammalian cells. The mechanism involves hydrophobic, based in the predominance of glycine and alanine amino acids. Use of micelle and gel suggests that these are important steps governing chain silk protein interactions toward organized silk structures. The final step involves assembled proteins that are spun through orifices in the abdomen of spiders. Biomatics involves silk spinning process mimicked in vitro. For example, is porous 3D sponges. Another functions are blending silk fibrin and polyethylene oxide, silk protein assembly, and engineered liquid crystallinity. On the other hand, synthetic silk analogs are also developed in laboratory. For example, are copolymers of glycine alanine repeats with polyethylene glycol.
And the next one is the seashells. It is a high-performance organic and inorganic composite from nature. The shells of a mollusk exhibits exceptional toughness despite composition of brittle inorganic cells. The mechanical strength of these shells can be attributed to these molecular interfaces as well as the complex hierarchical structure consisting of ordered lamellae or layers. The interlining of seashells is called the nacreous layer. It has a 3 order of magnitude and that increases mechanical strength. These inorganic bricks are polygonal aragonite tables separated by a thin layer of soluble and insoluble proteins that act as the mortar. The organic matrix consists of insoluble B, serine, and silk-like proteins and do not contribute to the mineralization process directly. Example of these are collagens that represents the bulk of organic matrix. And mechanism behind the seashells is organic matrix. The organic matrix of the nacreous layer in the mollusk shell is flexible and contributes to the strength and toughness of the shell. It acts to dissipate crack propagation. The biometrics involving seashells includes ceramic materials and silicon carbide layers coated with graphite, which results to a material that has 4-fold increase in fracture toughness when compared to the And the next one is the shark skin. Sharks are in the class of contractites or cartilaginous fish that includes rays, skates, and others. Shark skin is paradoxical to principles of fluid dynamics since rough surfaces increase drag, and it is considered rough due to the tentacles. Ribless channels the laminar flow over the skin to further reduce drag after the larger structure. Tentacles create a boundary against turbulent flow. Without the riblets and the tentacles, the water would flow over smooth skin and suffer the full effect of friction. The 3 factors that affect the drag reducing properties of riblets are sharp edges riblets, The second is the riblet protrusion height, and the third one is the lateral spacing of the riblets. Biometrics involving the shark skin are used in swimsuits, wetsuits to develop new design to reduce drag in water to improve times for competitive swimmers or to improve navigation of scuba divers.
Next one is gecko and purse. Gecko lizards do not have suction cups on their feet but able to climb up walls and stick to the ceiling. Patay is a toe pad consisting of hair-like structures. Adhesion strength related to the polarity of substrate. The more polar, the better. Next is the mechanism. Van der Waal force. It do not secrete sticky materials, but it can adhere to different surfaces. The biometrics involving gecko lizards and purse includes new tapes that been designed, develop dry adhesive to eliminate sticky residues left and lastly, it is about muscles. Muscles, a band of bundles fibrous tissue in human or animal body. It is classified into skeletal, cardiac, and smooth. Muscle contraction, based on cross-bridge cycle and Lime-Taylor actomyosin AT-based hydrolysis kinetic scheme. Skeletal muscles involves voluntary movement. Cardiac muscle involves involuntary movement. Biometrics involves actuator, a controllable machine that converts energy to mechanical work by means of shape or dimensional change.
In conclusion, the biological materials in engineering methods illustrate the diverse and functional materials that are available as blueprints for exploitation in the broader field of materials, science, and engineering. However, significant hurdle will remain for some time for synthetic systems to fully emulate the novel features of natural materials. More crossover between synthetic process for polymers and models from biology will be realized, and lastly, biological and synthetic approaches may provide a useful bridge toward the future.